All right, there's two types of formulas. There's an empirical formula and a molecular formula. We're going to focus on empirical formula for this lesson. An empirical formula is the reduced form where you see the smallest whole number ratio. To figure these out, what we have is the percent composition of the formula, and then we have to work backwards to actually get the ratio. So if they're given in percents, you just assume there's 100 grams and you change your percent to grams or percent to a G. Sometimes they're given to you in grams, and so you can kind of skip that. You convert all of them to moles. So we're going to go back to the conversion tables to convert to mole, and since we're dealing with grams, we would use their molar mass from the periodic table. Then you're going to divide by the smallest number of moles. So out of all of the elements, the smallest number of moles, coming up with that ratio. This should give you a whole number. So if it's 2.98, you can go ahead and say that it's 3. However, you have to watch out for 0.5 or 0.49, which is the same thing as saying 0.5. That's too close, that's too in the middle to be able to round up or down. So what you do is you leave it as 2.5 or 3.5 or whatever it is, and then you multiply all of the elements by 2, and that gets rid of the 0.5. And so then you have the smallest number ratio. If the number ends in 0.3 or 0.6, then you multiply all of the elements by 3. Once you have those ratios, then you can write the formula. Don't forget to do that last step. That one, for some reason, everybody forgets. Once they get the ratio, they stop. But you do need to write the formula. So here's our first example. It says the compound contains 32.28% sodium, 22.65% sulfur, and the rest is oxygen. So before we actually start, we need to figure out how much is oxygen. So if we have 100% and we subtract the percent that is sodium and we subtract the percent that is sulfur, we would be left with the rest, which is oxygen. So if we were to do this subtraction, we would have 45.07% oxygen. Now, what we're going to do is we are going to pretend that we have 100 grams, so that this is 32 grams, this is 22 grams, and this is 45 grams. Then we can convert to moles. So we take our grams and convert them to moles. It doesn't matter the order that you do these in. Personally, I like to do them in the order they're given, so I don't skip over any. And because when you write the formula, you want to write them in the same order that they're given. So we would say 32.28 grams sodium. Draw our table. We're going to bring grams of sodium diagonally down to the bottom so we can cross them out. And we are converting to moles, so we put mole on top. 1 mole, and then the molar mass goes with grams. So looking on the periodic table, we get 22.99. And we are going to multiply and divide, so grams cancels out. We want to use the same number of significant figures as the given, so 4 digits here. Our answer is going to be 4 digits, and we would say 1.404 moles of sodium. Do the same thing for the sulfur. Bring grams to the bottom, mole on the top, 1 mole, and then the molar mass off the periodic table. We would multiply and divide, and so that cancels out our grams of sulfur. We want the same number of significant figures, which again is 4, so we would say 0.7063 moles of sulfur. And then one last time for our oxygen. We would bring grams of oxygen to the bottom, moles of oxygen on the top. 1 goes with mole. The molar mass of oxygen from the periodic table goes with grams. We would multiply and divide, so our grams of oxygen would cancel. Keeping the same number of significant figures, 2.817 moles of oxygen. That's step one, and I know these problems seem really long, but just keep with it. Now we need to figure out what's the smallest amount of moles to come up with our ratio. So if we're looking here, sulfur has the smallest amount of moles, so we're going to divide all three of these by this value. So we're going to say divided by that, of course, would give us 1 sulfur, so you should always end up with one of the elements being 1. Divide this, and it comes out to be just about 2 sodiums. Remember, we want whole numbers unless there's a 0.5, 0.3, or 0.6. For oxygen, this gives us 4 oxygens. This is not 40, this is 4 oxygens. Then all we have to do is write the formula. So these values become your subscripts. So we have 2 sodiums, so Na2, S1, O4. Remember, ones are understood, so we don't write those as subscripts. So this compound is Na2SO4. It is also asking for the name. So you have to remember that this is ionic because you have a metal, and then we have this polyatomic. So we're going to use our ionic naming rules from our last unit, and we would say sodium sulfate.